Okay, folks, don't hate me too much as I bring you back to the uncomfortable days of high school trigonometry, where you scratched your head and tried to remember all of these discussions of angles and cosines and sines and all that stuff. I promise that we're going to use this for some creative purpose, but we're going to get through an initial challenge. What if I said to you, I want you to draw a circle to the screen, but you can't use the ellipse function? How would you go about that? Some of you might be inclined for this kind of thing, but most of you would probably say, I have no idea to do this. All right. Why would you want to do this? Well, we're going to mess with that circle after we draw it without using the ellipse, so bear with me. I'm going to go over to the whiteboard, and I'm going to confront you with some probably less than fun memories of trigonometry. All right, let me grab a highlighter here. Okay, here's what we've been doing to date, right? So we have been throwing some coordinates on the screen, where we'll say something like, "Oh, put a point or something at X position 3 and Y position 2," or something like that. And maybe we have been, taking that for granted, that we know, okay, we're going to go over 3 on the x-axis and up 2, or of course, I'm doing this in math for now. Our canvas starts at the top. It starts at the top left and then works down to the bottom right. But let's go back to our Cartesian plots in math class for a second, okay? So we know that we're going over 3 and up 2, and then there we are at position 3, 2. That's probably comfortable to you, but what you may or may not have thought about is that we're actually drawing a bit of a triangle here, right? Where we have some legs, well, let me see. Here we have the x position and the y position that form two legs of a triangle, and then we're kind of inferring a hypotenuse of some sort that we don't have to think too much about when we're plotting in Cartesian. But there's one there, and if we wanted to know what the length of that thing is, we could actually figure it out using the you could do the quadratic equation, but a squared plus b squared equals c squared, right? So that's something that high school probably ground into your head, I hope, and it's not too unfamiliar. But what if instead, if we go over to the right-hand side here, that I gave you the hypotenuse, or I gave you, a radius, and said we're going to go around the center of some middle point, and we're going to swing some radius around a circle, right? And we're going to do it at different angles, and at any point in time, I'm not exactly sure what my x position or my x value or my y value is for this point that I'm drawing here. But I do know the angle, and I do know the length of this radius that I'm swinging around. So how could I get that xy position so that I could actually plot a point there if I knew a value of a radius and a value of an angle? Well, you probably have seen this. If not, welcome to trigonometry. This is something that is going to allow us the capability to get those x and y values that we need. So if you want to find out, let's say, the y value, and you know the radius, and you know the angle, then you can get the sine of the angle. Well, I'm going to back up, okay? The sine of the angle is equal to y over the hypotenuse, okay? Which, if this is our angle, you say that the side opposite the angle is y, and the side adjacent to the angle is x, okay? Now we don't know y. We only know the sine of the angle and the radius. So we can use this formula to find y. We can take our radius and multiply it by the sine of our angle, and then we'll get our y position to give us that point. Likewise, rather than using the sine function, we can use the cosine function to get us the x value. Okay? Now, this might be as clear as mud to you. It's probably, I'm doing kind of a crappy job of explaining it. But what this is going to allow us to do is to do some generative art with this math. So you don't really need to be a trigonometry expert, but I think that if you can at least kind of understand what we're doing with this basic thimbleful of trigonometry, you'll be able to quickly do some cool stuff with it. And let me show you. Here, hopefully this will be the payback for your pain. Okay, let's go over here. All right. So just like we had in our little whiteboard discussion, I am going to declare a couple of variables that are going to hold what's the center of our circle that we're going to spin around, and the radius. All right. I'm going to set up a canvas, 600 pixels square. I'm going to initialize the radius value to be 100 pixels. So I'm going to draw a circle, 100 pixels radius, 200 pixels in diameter. All right? I'm going to put it right in the middle of the screen with its center at width divided by 2 and height divided by 2. Okay? Basic dark gray. I'm going to be drawing some points to the canvas that I want you to be able to see, so I actually made them a little bit bigger, 4 pixels. All right, into our draw loop we go. I am going to look at this for loop, right? And I am declaring within my for loop a variable called angle. And I'm going to give it values from 0 to 360 degrees in increments of 10. Okay? Hope that makes sense from our for loop discussions in the past couple of weeks. And as we know in P5.js and processing and most other stuff in JavaScript, when we're messing around with angular measurements, they work in radians as opposed to degrees. I tend to think in degrees, so this line 36 is just converting my degrees measurements to radians, okay? And I'm just calling it my angle, and that's the value, the variable that's going to hold the value for my angle each time we go through the loop. So the first time, my angle is going to be 0 because that's what we initialized it to, and then it's going to be 10, and so forth, all the way to 360. All right. We're going to get actually we're going to get the x and y positions of our point by this comment makes no sense, but I will fix it before you see it. We're going to get the xy position of our point by taking the radius times the cosine to get the angle. All I'm doing here is I'm adding it to the center position, that 200, right, that we're at. Oh, I'm sorry, not 200. Width divided by 2 and height divided by 2, the middle of the canvas. So all I'm saying is, all right, start at the middle of the canvas and then just extend my radius times the cosine of my angle, and that's going to give me an x position. So the cosine of 0 and the sine of 0 are going to the cosine of 0 is 1, and the sine of 0 degrees is 0, I believe. I may have that backwards. I don't know. I think that's the case. But anyway, it really doesn't matter. All I know is that to get the y position, you get sine times the radius, and to get the x position, you get cosine times the radius. And then we're going to put a point at whatever we calculated for those values of x and y. Okay, and we're going to put the point there for 0. We're going to put the point there for 10 and 20 and 30 and 40 and so forth. And then what we're going to get is this. Okay, it's a series of points in 10-degree increments, all the way around that radius that we're swinging, and we are, in essence, drawing a circle of points using only trigonometry, no ellipse function. All right? So, what if instead of points, we wanted to draw a line between those points? Okay, so let's comment out the point thing for a second, and let me uncomment a couple of lines of code here. We'll go all the way down here, and I'll explain them to you. Okay, going up here, I'm going to go back to the top of the sketch where I initialize some variables in setup, and you'll see that I'm going to create a declare these up top. All right, I'm going to create a couple of variables that are going to hold the previous position of the previous XY point that I drew before I move my radius and swing it to the next point. The reason I'm doing that is that I want to remember that point so that I can draw a line between that previous point and the one that I'm going to draw in the current loop. All right, so that's the goal of these variables. Now, the first time that we go through the loop, there is no last previous point, right? There's no last X or last Y point because we're going through for the first time. So I am in setup, I'm initializing these to just some arbitrary minus 999 value, which is sort of a dummy value that I can just use as a check. So the first time around, it's initialized to some kind of garbage value, and then I'm going to use a conditional to say, well, if this is the first time around, then I'm going to check and say, okay, you know, if these X and Y values are minus 999, then that means it's the first time around, so I don't draw a line. But every other time, I am going to draw a line between the previous point and the one that we're currently dealing with. All right? So that's how I'm going to approach this conceptually. And then in line 46 here, you'll see that I have that if condition, and I say in the condition, I'll say, okay, if this isn't the first time through the loop, in other words, if last X value is not equal to minus 999, then draw a line from XY, which we calculated up here, right, to last X, last Y. Well, what is last X, last Y? Last X, last Y is actually assigned right down here at the bottom of this draw loop, just before we go back up to the top to start our next cycle. We say, hey, before I do that, let me assign the current value of our X and Y to last X and last Y, okay? And now we're saying, okay, we're going to call this now our last time through the loop, and now we're going to go back up to the top, and we're going to assign new values for X and Y, and we're going to draw a line between those new values and the ones that we just assigned in the cycle before. And that will allow us to draw lines between those circles. Draw lines between those points to make a continuous circle. All right? So that's all well and good. And why do we go through all this effort just to draw a circle with crazy math instead of just saying ellipse? Well, consider for a minute if we wanted to do something like change the radius. Rather than just having this constant 100 pixel radius, what if we decided we wanted to start our radius, at 10, and then gradually grow it out every iteration through our loop, and instead of making a circle, what if we wanted to make a spiral? So that's very easy to do with this kind of a function. Okay, so I made a couple of changes to the last function. You'll see that I'm still using that last X and last Y point, and we're still having a variable to hold our position of our center and our radius, which we are now starting at 10, and we're going to spiral out. Okay, so a couple of quick changes. The line is the same, and then we remember our last coordinates the same way, except each time that we go through the draw loop, we increment our radius by half a pixel or so. Okay, and rather than going through our for loop as 0 to 360, Now I'm going to actually spin out like 4 circles, and we're going to draw a spiral. Okay, each time through, we start at 10 and then a little bit more, and then, we're at 20, 30, 40, and before you know it, our radius is, hundreds, 200, 300, and then we're drawing a spiral. So that's kind of cool, right? And now what if we decide to go a little bit further with that and add a little bit of Perlin noise to the position of that point that we calculate for each of our radius, right? So it's the exact same sketch this time around, starting at 10 for a radius, and we're going to increment our radius a little bit. But instead of drawing the radius, officially to the point we calculated, this time around we're going to add a little bit of noise to the radius in line 34. You'll see that radius is equal to the radius plus a little bit of a noise function that I put in here. And I honestly just messed with, if you remember, our Perlin noise value only returns our Perlin noise function only returns a value between 0 and 1, which we then have to scale somehow. And I just messed with different numbers, quite honestly, and came up with something that looked pretty good. When I multiply it by 200 and then subtract 100, that means nothing other than it's a function that I applied to the noise to make it look kind of funky. And then what we get is something that looks kind of like a flower or an explosion, or I don't know what it looks like, but it looks pretty cool. And this is just a spiral with a little bit of noise injected in between the various iterations of our loop. Now we could change these values rather than incrementing the noise by 0.5. Let's say we wanted to go 0.03, just a small increment. We'll just kind of have like a little bit of a wobbly spiral, right, with a little bit of noise. Rather than incrementing the radius by 0.5 each time around, what if we decided to do 0.1? I don't know what it's going to happen here, but now you get something that's a little bit more like a squiggly line. It's it's up to you to decide how you want to work with these creative functions, but this is how you do it. You really, that's kind of where we left off, which is where I'm going to save it. Okay. Now here we are with one of these things being drawn at a time. What if I wanted to take this spiral and kind of layer one atop another and maybe do 20 of them, right? So in this sketch, I will do that. I'm going to continue on the creative path that we started. Everything is more or less the same. This time around, I'm going to be injecting a little bit of color into the mix. So I'm actually going to blend each of the little spirals that I draw one atop the other. So I'm using the P5 blend mode function, which gives us that Photoshop overlay, soft light capability, screen, multiply, that sort of thing. Again, I found it in the reference. It's in there. Going through, I am now just drawing a stroke for some random color that I sort of biased a little bit more to the blue-green palette. So I'm drawing a stroke with a random value between 0 and 200 for red, and then between 100 and 200 for green, and 100 and 200 for blue. So it's got a little bit more blue value inherently than it's got red value. And I'm going to vary the weight of each of the strokes that I draw within the function between 0 and 5 pixels. So each of these spirals will be some random stroke weight, I should say. And now I'm going to go through the loop just as we did the last time, with a little bit of our noise injected in, just as we did. And I'm going to draw 20 of these things on top of each other, right? And I did one final thing at the bottom of the sketch where I say, let's add an event. And when the mouse is pressed, what I want to do is I want to clear the screen. I want to reset the loop count to 0 because I'm actually counting. I should actually mention this, that I'm going through with a counter and I'm counting 20 draw cycles. you can see each time through draw, I start with my loop count is 0, so it's 0 the first time around. I draw the spiral just as we did, and then I increment our loop count to 1, right? And then I check with a conditional here that says once the loop count gets greater than 20, then stop looping, stop drawing, stop the draw loop. So I use the P5 function no loop, which stops this draw loop from cycling back on itself. Okay, so it gets to 20 and then it stops. Then when I click the mouse, I reset that count back to 0, so it's going to draw another 20 again, and I start looping again, start the draw loop back up. And that's all I do. So I just run that again and again. Each time it's a little bit of a different figure. You know, it actually looks kind of cool. I think I did it in CodePen. So I could do a... bear with me here for a second. Okay, my pens. Where are my pens? Ed's pens, my dashboard. Okay, view. There it is. All right, sorry. I will change this to a full page view, which frustratingly the P5 online editor does not have yet. So it's kind of cool, right? So, you know, this is truly generative art. Now, all of this is inspired by a book called Generative Art, oddly enough, by a guy named Matt Pearson. It's a great book. It's written for processing, but the examples in here are very understandable and easily portable into P5.js. This, you know, I started with some ideas here, and I worked up the example that I showed you, but all of the spiral idea came from here. Right? How to draw that ellipse using trigonometry came from here. There are so many cool books that I think bear mentioning. Processing, a programming handbook, is actually like the Bible of processing. It's really good. It takes you through all sorts of illustrative examples of all kinds of things, you know, noise and opacity and color functions and everything, complete with code examples. Again, the code examples are in processing, but the syntax is so familiar to P5.js that I highly recommend it. Another book, which is absolutely beautiful. This is a book, it was written originally in German, but it's called Generative Design. And it's like a coffee table book. Beautiful examples of all sorts of cool things that were done in processing, you know, like whether it's 3D printed stuff or, you know, all kinds of cool examples with noise and function. And all of the code is provided for each of these concepts as well. So this is not an inexpensive book, but it's worth really every penny. It's beautiful. So that's a little bit of generative art for you. If you're not quite ready for this, if you're a beginner, rote beginner, and this is all like you want to drop out of this class, don't drop out of this class. But for some of you who are a little bit more into, you know, being able to code this kind of stuff right out of the gates, I thought that it would be fun to share this with you. Now, we're using one for loop, a little bit of noise, and you know, just a teaspoon of our high school trigonometry, explained, you know, exceptionally poorly by me, but hopefully you guys remember enough of that the concepts themselves are not completely foreign, and that, you know, just swinging that radius and angle around allows us to do some cool things with it. I mean, really, the sky's the limit. We just mess with a spiral, but you could do all kinds of stuff with this little bit of math. And lots of generative art works just this way. We say, okay, I'm going to give it a couple of instructions and get it on its way, but I don't know exactly what it's going to turn out as. So that is it for this week. Go forth and loop, and I hope that you guys have a lot of fun with it. Surely we're available, you know, in the forum for questions or in the sections. Delia and Brian will be there to talk you through any and all of this stuff. So have a great week, and I'll talk to you next week.